Our planet was born in violence and grew with disaster. 4 billion years ago, primitive life may have been drifting in the oceans, but disaster loomed. The seas were lost to intense heat, yet science tells us life survived. Deep underground, it waited for the oceans to return. Life's goal is to survive, no matter what. And survive it did. First through fire, and then through ice, on a miracle planet. Today, New York is a thriving cosmopolitan city, one of the great cities on Earth. Yet 20,000 years ago, this whole area was covered by vast sheets of ice. Glaciers ground their way through Central Park. Large rocks that have no right to be here. It's as if they were dropped erratically by some mythical giant. Before geology was a science, it was recognized that they were from another place. Some thought they were the debris carried by the waters of Noah's flood. They were carried by water, but not liquid water. Ice. To the north, Greenland is still a country of ice. Large rocks locked in glaciers are slowly transported away from where they were originally formed. Glaciers move very slowly. Their forward motion can be measured in years rather than in distance. But when the ice melts, the cargo it carries is dropped. Geologists call these rocks erratics, or dropstones. For science, they are important pieces of evidence. They give clues to the evolution of life. Erratics are found across the globe, and they are proof as to which parts of the Earth were once covered by ice. 20,000 years ago, some parts of the world were locked in ice. In Canada, near Lake Huron, there is evidence of a far earlier ice age, when the entire globe may have been frozen. Mike Hailston, a district geologist with Canada's Ministry of Northern Development and Mines, knows where to find rocks that predate the last ice age by billions of years.
This is the one that I wanted to show you. It's an Archean granite boulder stuck in a rock that's 2.4 billion years old. It's a diamictite formed from a glacial action that occurred 2.4 billion years ago.
Throughout the region, there are rocks and gravel sediments that really have no place in local geology. They are all between 2.2 and 2.4 billion years old. Older rocks are found in younger strata, as if the Earth has constantly recycled its crust. The rocks have been moved by continental drift, as well as by glaciers. To try and locate where they originally came from takes us back into the past. Glacial sediments over 2 billion years old have been found in at least 7 different parts of the globe. Until fairly recently, trying to pinpoint where they came from has been purely educated guesswork. Namibia in southern Africa is an ancient landscape carved by wind and erosion. But glacial sediments also show that ice once played a major role. Now hot and dusty as well as isolated, it is a hard country to work in. For geologists, though, it can be a paradise. Dr. Joseph Kirschvink is from the California Institute of Technology. His specialty is magnetics. The Earth is surrounded by magnetism produced by its own magnetic field, the way compasses work. Long ago, as they formed on the Earth's surface, the jagged rocks in this riverbed were molten lava.
We are sitting on some lavas that erupted 2.2 billion years ago during a time of a very large glaciation. It's very nice because when the lavas cool, they preserve the direction of the magnetic field, and from that we can measure the latitude.
Molten lava contains many minerals which are magnetized. As the lava flows, these minerals follow the magnetic force of the Earth. Once it cools, the magnetic direction of that moment is fixed forever. It is then possible to locate exactly where the rock was formed. To do this, one matches the magnetic history of the rock with the angle of the lines of geomagnetic force that surround the planet. Once that has been determined, the latitude can be fixed. At the center of the screen is the pole. The further away a point is from the center, the closer it is to the equator. When the samples from Namibia were analyzed, their magnetic compasses pointed to the fact that they all had originated near the equatorial regions, closer to the equator than Hawaii and Guam are today. This confirms that over 2 billion years ago, there were glaciers near the equator.
To have glaciers there at that latitude implies that it has to be colder as you go north. Hence, the entire Earth, right down to the equator, had to have been frozen.
Not once, but twice, for glacial sediments in strata dated between 800 to 600 million years ago. From this data, Dr. Kirschvink put forward the proposal that the Earth had been completely covered in ice at least twice in its history. It was called the Snowball Earth, and like many scientific theories, this one is hotly debated.
Oh, that's not.
Okay, now.
Children always enjoy scrambling around looking for rocks.
Hold it close to your eyes. That means you're going to go right down on the rock.
And there are few better teachers than Dr. Paul Hoffman of Harvard University. For years now, his passion has been geology, and he is also a keen advocate for Snowball Earth.
The impact of the snowball events would, of course, be much more severe because organisms might try to escape towards the tropics, but eventually in the oceans, the ice will completely envelop the tropics because this ice is flowing. It will move into the tropics and meet at the equator.
Working with scientists at the University of Tokyo, a computer simulation was carried out to show what would happen to today's world if a snowball Earth event were to occur. At 35 degrees north, Tokyo is just a little further south than New York. Ice up to 1,000 meters or 3,000 feet thick would bury the city. At first, any life that could not find shelter would freeze to death. At the start, the glaciers would move slowly, it would take millions of years for the ice to reach a latitude where Hawaii and Cuba are. But from there to the equator would take only a few decades. Paul Hoffman thinks that the sea might freeze down to a depth of over half a mile. Some life might escape under the ice, but only for a while. For sunlight would be cut off, and the base of the food chain would die.